All right, folks, here we are with the second part of bias. Some of the most important parts of our epidemiology studies are how to both create and critique biomedical research in the literature. And so we are going to be spending lots more time on bias. We have already covered sampling or selection bias, and now we are going on to confounding. To be confounded is to be pointed in the wrong direction or led astray, being mixed up or confused. Whereas bias is a flaw in study design, sampling, or data measurement. Bias is something that will cause a study to be flawed either randomly without any known result towards a positive or negative result, or it may be purposely flawed in order to give a desired outcome. Confounding bias is an interaction between two variables leading to correlation with a third variable. There is something different about one group that leads to an association with an outcome. These are all various definitions of confounding. A confounding variable is an underlying characteristic more prevalent in one group than another. As I said in the earlier slide, confounding is when there is something different about one group than another leading to a false conclusion. So a confounding variable therefore is an underlying characteristic more prevalent in one group than another and leads to correlation between that group and the characteristic or outcome of interest. And this is the definition that I use most frequently, and that is confounding. A confounder is an independent risk factor for the condition which is also correlated with the exposure of interest. We're going to spend some time on this so we can give you some examples. So hopefully a confounding will be quite clear to you and not something that leads you astray. So here's a real simple one. What's wrong with the conclusion that hospitals or nursing care increases the risk of death? In other words, hospitals must cause death because more people die in hospitals than almost any other place. Well, obviously you know that is not true, and this is a simple example of confounding. Sick people are more likely to go to hospitals. Elderly or disabled people are more likely to go into nursing care, and sick or elderly people are more likely to die. Therefore, the confounder is age or degree of illness, which again is correlated with age. These are independent risk factors for death, the outcome of interest, and are correlated with the exposure, which is hospitalization or nursing care. We're going to spend a little time about myopia. Myopia is nearsightedness for those not in the eye care field. There were old assumptions about kids who wore glasses were smarter than kids who did not wear glasses. And so there was this assumption that either glasses caused intelligence or intelligence caused the need for glasses. So people with glasses, actually people who are myopic or nearsighted, do tend to be smarter. This is a fact on average. Why would this be? Well, it could be that nearsightedness causes increased intelligence. It could be that increased intelligence causes nearsightedness. Or it could be a confounder, such as reading. Those who read a lot learn more, and those who read a lot are more likely to get myopic. So here, reading is the confounder. Reading is an independent risk factor for myopia and is also correlated with intelligence, or at least knowledge. Now if there are any psychologists listening, I am just going to kind of use intelligence and knowledge interchangeably here, okay? Now, specifically, IQ or intelligence is generally an inborn trait. I recognize that, but in this particular lecture, I am going to suggest that, or simply use intelligence and knowledge as interchangeably, because those with more knowledge tend to be considered more intelligent. Whether their IQ is actually higher than another is not going to be relevant in this particular lecture. So just relax about those particular usages, please. And I beg your pardon. So, which is the cause of myopia then? If myopia is correlated with intelligence, as well as these other things, educational level, parental history of myopia, race, Asians are much more likely to have myopia than African Americans or whites. Socioeconomic status is also correlated with myopia. Higher economic status, on average, has a higher prevalence of myopia. Time spent indoors, believe it or not, is correlated with myopia. And the amount of near work, and there are geographic aspects, which again is probably more a proxy for race than anything. Well, let's take a first potential cause. Myopia is genetic, is it? Well, let's look at our risk factors. If you do not have a parent with myopia, then you have very low risk, about 10% overall for your lifetime. If you have one parent with myopia, then you have a moderate risk, about 25% overall. If you have two parents with myopia, you have a high risk, at least 50% chance of developing nearsightedness during your lifetime. So certainly there does appear to be a strong trend here in terms of myopia being genetic. And as I explained before, Asians are much higher prevalence of myopia, 70 to 90% lifetime risk, whereas blacks have a much lower risk in the only 14.5% overall. So there seems to be a strong racial and genetic component, and we are going to assume that race is biologic compared to culture or ethnicity, which is not biologic, that race certainly is genetically determined. But others say, wait a minute, myopia is environmental. It is caused by environmental preferences. Pressures. Look at these statistics. For example, the prevalence of myopia at birth is less than 1%. Even up to age 5, the prevalence of myopia is less than 1%. Well, if it's genetic, how come you're not born with it? Age 6 to 9, the prevalence jumps up to 4 to 10%. Age 12 to 17, 26%, and greater than age 17 for all races is 37%. And so if you look at this figure from the study by Muti et al., you will see that at age 6, starting, you see a linear climb of myopia up to age 13. And if we extended that graph to the left to younger ages, it would be a flat line from 6 to birth. And if we extended it greater than 13, it would continue to climb, but probably not as steep. So something happens starting at age 6 and continues to happen through the teen years, and therefore we must start to think about, well, gee, it must be environmental then, right? If you're not born with it, how can it be genetic? If it happens only around age 6 and up, which is not coincidentally, the start of school and learning to read and doing more mirror work, that prevalence of myopia increases for every additional year of education. The risk of myopia in 8th graders is 20% when one parent has myopia and 33% when both parents have myopia. So maybe there is a genetic factor there as well, because it's much higher prevalence in those with parents with myopia, and of course we have said race has a strong factor in myopia. So also myopia is more prevalent in children who read a lot. Myopia is more prevalent in children with higher reading and language test scores as well. So it seems that the answer is both. Myopia is both genetic and environmental. Does this fit with our understanding of cause and effect of conditions? And are there confounders at work here? Well, let's think about this. Parents who have myopia have higher income, have higher education, tend to have children who read a lot, and the children have higher intelligence, perform better on reading and language tests, and develop myopia. So is that hereditary or is it environmental? Are these children reading a lot because their parents have higher education or higher socioeconomic status and impress upon their children the need to perform better in school, or tutor them, or penalize them when they don't do well, and therefore they read more? Or is it because they both have certain genes that leads to the development of myopia? Well, the big question, therefore, then, is why is it largely absent prior to grade school? Okay, well, reading may be a cause, but also kids who read a lot tend to stay inside more. So maybe reading is a confounder, and exposure to sunlight or being outside, maybe that's the actual cause. Some studies have found increased myopia with increased time indoors, but others have not, even when controlling for reading time. So there may be some questions there yet to be answered. Do kids who read a lot get myopia, or do kids with myopia not like sports, outdoor activities, and instead read a lot? Again, which came first? Next question, are kids with myopia more intelligent because they read a lot, or are they genetically more intelligent, read a lot, and then develop myopia? So, myopia is actually a multifactorial condition. There is not one cause and effect. And you have both associations as well as causes. So here, on the inner part of this model, I have the most likely causes, and that is parental or hereditary, race, also genetic, the amount of reading, and the subject's age. In other associations, which would qualify as confounders, we have income, family income in general, IQ, or just intelligence. And again, here I'm responding more about knowledge and intelligence as a potential that can be molded, not just the innate IQ. Geography, well, of course, geography is associated with race, so that's a potential confounder. And education level is associated with just about everything, with the parents' education level, with the family income, with intelligence, etc. But wait, there's more. There are also associations with IQ. If we reverse the model, we have parental IQ, we have health history, we have cognitive speed and perceptual skills. These are all possible either innate or causative factors for high or low intelligence. And then, of course, we have the potential confounders, which are myopia, geography, education level, and income. So teasing this out now, The various possible causes of myopia could also be considered confounders. The purpose of this lecture is not to try to convince you of one particular cause of myopia or even the multifactorial model of myopia. The purpose of this lecture is to show you the role of confounding and why it is so hard to come up with a very specific model of cause and effect for myopia. Because confounders are, again, memorize this definition, independent risk factors that are associated with exposure. For myopia, the strongest association is genetics, but the environmental influence is impossible to ignore. What I tell my patients who ask, well, how did they get nearsighted, or did they get their nearsightedness from me? I say, well, myopia is caused by a genetic predisposition and stimulated by the environmental influence of reading and near work. And there you have it. There was, just a sidebar, there were some famous mid-20th century reports done by Morgan who compared myopia prevalence in Inuit communities before and after the United States instituted reading in schools for the communities. And so the elders who had not learned to read or received formal schooling had almost no myopia, but the children in the community that were the first generation that attended school did develop much, much higher amounts of myopia. And so this, again, was initially thought that, well, there it is, reading causes myopia. But again, selection, think about your sample. Inuit communities are related to Asians, and so they are going to be predisposed for myopia. All right, enough on nearsightedness. Let's see if we can look at something else. In a certain county, there is a higher incidence of cancer in rural households using well water compared to village households using municipal water. Villages tend to be in valleys near rivers. Well water households tend to be in the hills. So homes built in the hills are excavated into granite bedrock. Homes in the valleys are excavated into soil. Suppose radon is present in the granite bedrock, but not in the river valleys with the fertile soil. Suppose radon is present in the granite bedrock, but not so much in the valleys with deep loam soil. Now, we do know that radon is carcinogenic, so therefore we have here radon as an independent risk factor for cancer and is correlated with the use of well water because the homes built in the hills are made into the bedrock and therefore more radon. So we can't really necessarily say it's the well water that's causing the cancer. It could be something else about the environment, such as the exposure to radon in the rock foundations. So confounding is common in cross-sectional correlation studies. It can also be a problem for the case control studies, and I realize we haven't gotten to the differences in the case control format versus a cross-sectional study, but and we will certainly remind you when we get to those types of studies of what their advantages and disadvantages are, and one of them is the ability to control for confounding. Now we also have the placebo effect, which you're quite familiar with. Now, placebo effect could be a type of bias all by itself, or it could be considered as confounding, since it is often going to be associated with an exposure and maybe a factor with outcomes, such as a treatment group. So any unmasked studies are going to be open to the placebo effect, which can be considered a type of confounding. So I have been talking about confounding on some slides and confounding bias on other slides. Why is this? Well, because there is not a consensus in terms of whether confounding is in and of itself a flaw in a study or if it is a subset of bias along with selection bias and information bias. So here's an interesting quote that I took. Technically, confounding isn't a true bias because bias is usually a result of errors in data collection or measurement. However, one definition of bias is, quote, the quote within the quote, the tendency of a statistic to overestimate or underestimate a parameter, which is what confounding does. So in this sense, confounding is a type of bias. So I put down a little because in the same paragraph, this author is saying confounding isn't a true bias, but in a sense, confounding is a type of bias. I don't care if you use confounding as its own entity or as a type of bias. I will go back and forth, and it is up to you if you want to just limit yourself to confounding. But there are others in statistics and epidemiology and science in general who will be quite upset if you use bias with confounding instead of simply stating confounding. Doesn't bother me though. So here's a question for you. Who are the most dangerous drivers? Argument 1. Young male drivers have the highest rates of motor vehicle fatalities. Whenever I have an elderly driver who cannot pass their vision test to continue the privilege of having their driver's license, many of them will be quite upset and remark that I've never had an accident and all these youngsters out there, they're the dangerous ones on the roads, etc., etc. Okay? So that's the argument. Young male drivers have the highest rates of motor vehicle accident fatalities. Argument 2 is no, elderly drivers have the highest rates of motor vehicle accident fatalities. Well, let's look into this a little bit. The key is rate of what? Whenever we talk about rates, we need to include, remember our discussion on incidence, we need to include the denominator. So the rate of what? Motor vehicle fatality rates. Are they fatalities per year overall, or are they fatalities per mile driven? If we look at fatalities per year, young male drivers clearly cause the greatest fatalities per year. But if we look at the fatalities per mile driven, it is about the same between those under age 25 and those over age 70. And in some statistics, the elderly drivers, those over age 80 or 85, per mile driven do have significantly higher rates of motor vehicle fatalities. And here are some numbers, because we're in epidemiology, we like to use numbers. So males age 25 and under in 2006, and this is United States data, I believe, 9,508 total fatalities, and that could be themselves the driver, it could be them hitting a pedestrian, it could be them hitting another vehicle and causing a fatality, whereas they live, or it could be a passenger in their car. This is simply total fatalities for males age 25 and under who are driving. Compared to males age 65 and over, only 3,315 total fatalities. So, almost a 3 times higher total per year number of fatalities for under age 25 compared to over age 65 or 65 and over. But as we talk about in today's society, 65 is the new 45 and 85 is the new 65. So with our life expectancies and our health quality much higher in our much later years, the old categories of 65 and over may not be the best ones to compare. So if we look at per million miles driven, males under age 25, 5.6 fatalities per million miles driven. Males age 70 and over, 4.0. Now, I couldn't get specific data for the age groups that I wanted. But the one to point out here is that once you're over age 80, it's actually about the same. And you can see that big change between age 70 to 79 at 2.4 fatalities per million miles driven compared to age 80 and over 5.5 per million miles driven. So again, 65, 70, 75, 79, we're talking a pretty low rate of fatalities, both total and per million miles driven. But once you hit over 80 plus, then it goes right up to be the same as the young man who simply are not mature and tend to be wild and reckless. There's the source for that data. And here's some graphs to try to show it as well. This box here I have put in to suggest that we ignore this section here because this is under age 16, and there are very few drivers under age 16. There are certainly some states that allow younger drivers under certain conditions. For example, my father-in-law, who grew up on a farm in rural Minnesota, was allowed to drive to and from school, which was something like 20 miles away on a very empty set of roadways, much younger than age 16. I don't remember exactly when, but they had those, that they weren't allowed to just go to town anytime they wanted to. There were limits in terms of what time of day they could drive and what the purpose was. So just ignore those down there because that's not a real representative sample. But once you get to age 16, then we're talking, a good number of teenagers, if not the majority, are getting their driver's licenses, and we got more representativeness. So if we look at deaths in passenger vehicles per 100,000 people, we're seeing that male drivers, first of all, are way much higher than any other group, suggesting that testosterone does increase speed, recklessness, and decision-making compared to females, which overall have much lowers. And then the thing to, again, look for is there a change in age? Okay, well, keeps going, it basically goes down from age 19 to 69, and then starts to climb up after age 70. Again, probably the biggest factor here now is gender versus age. So the confounder would be miles driven. Both young and elderly drive much fewer miles than working age adults, but the elderly drive even fewer than the age 25 and under. So I will leave it up to you to decide which is the more valid comparison, fatalities per year or fatalities per mile driven. Certainly some reasons for the high rates differ. The young drivers will generally be more likely to be drinking and driving or using other intoxicating substances. They will tend to be with groups, out carousing at night, and again, their brain development is certainly not fully there until at least age 25, and again, there is quite a difference in gender on that as well. However, the young folks have quicker reflexes, better coordination, are more physically fit, certainly. Whereas in the elderly, I suspect the main causes are physical impairments. It is well established that our reaction times are slower, and our cognitive speed is slower, and our strength and coordination is less. Add in some vision and hearing impairments, and even actual health emergencies, such as having a heart attack or a stroke in the act of driving. So, and I can assure you that my reaction time at age 55 is much slower in terms of my ski racing abilities. And I can also tell you my My per mile pace on the 5K, 10K, and even marathon is definitely slower than it was 10, 20, and 30 years ago, despite equivalent training. Okay, this will conclude the section on confounding. And so on to the next lecture after you've had a break, which will be bias part 3. So that will be information bias or measurement bias or misclassification. Lots of names for the same thing. Good night for now.